Ever stop to think about what goes on behind the scenes with the cars we drive? You know, the invisible stuff, the hidden processes.
It's easy to just see the final car,
Right.
but underneath there's this whole world of specialized manufacturing.
Exactly. And today we're doing a deep dive into one of those really crucial but often overlooked areas, automotive die casting lubricants. We'll be looking at market trends and what the future holds.
It sounds niche, but it's fascinating stuff. Our mission here is really to um, pull back the curtain on these lubricants. They play such a vital role in making those lightweight, high-performance parts.
And we want to unpack the trends shaping their future. The idea is to give you a really solid grasp of this market because it has surprisingly big implications way beyond just cars.
That's right. And we're basing this discussion on a pretty detailed market analysis from Cognitive Market Research. It's got some great insights.
Okay, so let's start right there. Automotive die casting lubricants. What are we actually talking about here? Is it just like oil for molds?
It's a bit more sophisticated than that. Think about molten metal, usually aluminum or maybe magnesium alloys,
Okay.
being forced under extremely high pressure into a steel mold. Or a die is how you get really intricate, precise metal parts for cars.
Wow, high pressure. Sounds intense.
It is. And these lubricants, they're specialized fluids that are absolutely essential for that whole process to even work properly.
So it's more than just making things, slippery. What are the critical jobs they're doing inside the die?
Oh yeah, much more. They do several really vital things. First, they drastically cut down friction and wear between that hot metal and the expensive steel die. Protects the tooling.
Makes sense. Protect the expensive bits.
Exactly. Second, they help improve the surface finish of the part being cast. You want smooth, high-quality components.
Okay, quality control. And third.
Third, and this is critical for speed, they help the finished part release cleanly and easily from the mold. No sticking.
Ah, so you can keep the production line moving fast. It sounds like these aren't just minor tweaks then, they're fundamental for the whole operation.
Absolutely fundamental. When you hear about enhancing productivity and efficiency on the factory floor,
Yeah.
this is what they mean. Faster cycles, because the parts release quickly. Fewer rejects, because the surface finish is good. And the dies themselves last much, much longer.
That's huge savings, I imagine.
It really is. And think about the parts being made complex structural things like chassis components, engine blocks.
Really core parts of the car.
Yes, transmission housings too, formed with incredible precision, all thanks to these lubricants letting the metal flow just right and then release perfectly.
We even have a specific example, right? Shanghai Youngmo Thai Automotive Technology. What they're doing sounds pretty cutting edge.
It really is. They're doing trial production of these large, complex structural parts using a special aluminum alloy that doesn't need heat treatment later.
Okay.
And they're using integrated die casting. That means forming these big, complex parts all in one go as a single piece.
Instead of making smaller bits and joining them.
Exactly. Traditionally, you might cast several pieces and weld or bolt them. More steps, more weight, more potential weak points.
So this integrated approach is a big leap.
Huge. And it's these advanced lubricants that make it possible. They provide the flow control and the release properties needed for these really complex single-piece structures, pushing the boundaries of lightweight design.
Incredible stuff. So given how vital these lubricants are, what does the market actually look like? Is it a big industry?
It's definitely significant and growing. The estimate for 2024 puts it around USD $1,354.2 million.
Over $1.3 billion, not small change.
Not at all. And the projection, it's expected to climb to over $1.9 billion by 2032.
Wow. What's the growth rate on that?
The forecast shows a compound annual growth rate, or CAGR, of about 4.50% over that period, so steady, solid growth.
Okay, 4.5% CAGR. What's driving that? What are the key factors pushing this market forward?
Well, one of the biggest drivers is that relentless push for lightweight components in cars.
Right, for fuel efficiency performance.
Exactly, and especially now with electric vehicles. Lighter cars mean longer battery range. Die casting allows for these complex, strong, but very light parts made from aluminum or magnesium.
So the rise of EVs is a major catalyst here.
A huge one. And tied to that is consumer demand and, well, economic factors too. As economies develop, more people buy cars.
More cars, more parts, more lubricants.
Precisely. And consumers themselves are shifting towards more fuel-efficient vehicles, which again points back to lightweighting.
It seems like die-cast parts have an edge there too, right? Something about strength to weight.
Yes, that's another advantage. Die-cast components generally offer a better strength-to-weight ratio compared to, say, traditionally forged parts, so that naturally boosts demand for the lubricants needed to make them.
And are the lubricants themselves getting better? Is technology within the lubricant industry also a factor?
Absolutely. Advances in the lubricant formulations are another key driver. We're seeing new products with better thermal stability. They handle the extreme heat of casting better,
Which means less breakdown, maybe better performance.
right? And also better environmental compliance. That's increasingly important. These improved formulations help manufacturers meet regulations while boosting efficiency.
Interesting. You mentioned implications beyond cars earlier. Is this market also growing because of other industries?
Yes, that's a really important point. While automotive is the main driver, demand is also being pulled by significant growth in other sectors too.
Like what?
They telecommunications, healthcare, even defense,
Huh. How do they use die casting?
for all sorts of precision components. In telecom, maybe casings for phones or network gear. In healthcare, parts for complex medical devices where precision is paramount.
Okay, I can see that.
And defense uses it for specialized parts where, again, that strength-to-weight ratio is critical. It just shows how versatile this manufacturing process and therefore these lubricants really are.
So it's a global market, clearly growing. But is that growth happening evenly everywhere, or are there specific hotspots?
It's definitely not uniform. North America actually had the biggest slice of the pie in 2023, around 35%.
35%. Why North America?
Several things feeding into that. The boom in EV sales is a big factor there.
Yeah.
Plus, lots of R&D and advanced manufacturing and, generally good access to cutting-edge tech.
Okay, and Europe, how are they stacking up?
Europe was next, holding about 30% of the market in 2023.
What's driving it there? Is it the green push?
Largely, yes. Strong government policies pushing for decarbonization, stricter environmental laws. That definitely shapes manufacturing choices.
And consumer attitudes, too.
And consumer preference, absolutely. There's a growing demand for products seen as eco-friendly, and that influences the whole supply chain.
Now, the really explosive growth seems to be in Asia Pacific. You mentioned it held about 25% in 2023, but jumps to 30% by 2024. That's a huge leap.
It is. That region shows the highest CAGR, projected at around 13%. It's really accelerating.
13%. What's
Yeah.
fueling that kind of growth?
It's a combination of factors. A major focus on innovation, a rapidly expanding industrial base, particularly in places like China and Japan.
Right. Huge manufacturing hubs.
Exactly. And just overall rising vehicle production across the region, China especially is seen as a key market with massive potential for these lubricants.
Okay, so it's a dynamic, growing market with clear regional differences. Who are the main companies competing in this space? Who's leading the pack?
It's definitely an intensely competitive field, but a few major players stand out.
Like who?
Based on 2023 data, Henkel, AG & Co. KGA had the largest share, around 19%,
Cool, okay.
followed closely by Chemtrend LP at 17%,
Yeah.
and then Quaker Houghton Inc. with about 15%. Those are the big three.
And what are they doing to stay ahead? Just making good lubricants?
It's more than that. They're constantly investing in R&D, trying to improve their products, find the next innovation.
Makes sense.
And they're also very active with strategy. Things like mergers, acquisitions, forming partnerships. It helps them broaden their product lines and expand their reach globally.
Standard playbook for market leaders, right?
Yeah.
Keep growing, keep innovating.
Pretty much. It's essential to maintain that edge.
And we see that playing out like with Quaker Houghton building that new plant in China.
Exactly. They broke ground on a big state-of-the-art facility in Zhangjiagang. It's slated to open in 2026, specifically aimed at capturing that booming Asia-Pacific market.
That kind of geographical move must impact innovation too, mustn't it? Does building in China mean developing different products than you would for, say, Europe?
That's a great question. It often pushes innovation on multiple fronts. You might need to adapt formulations for local conditions, regulations, or even specific customer needs in that region.
So regional adaptation.
Yes, but often the learnings from that, maybe developing a more heat-resistant formula for a specific Asian climate, can feed back into their global product development. So it drives both localized and universal advancements.
Interesting dynamic, but as we said, it can't all be smooth sailing. What are the major bumps in the road for this industry? What challenges do they face?
Well, a really significant one is the cost of raw materials. It can be quite volatile.
What kind of materials are we talking about?
Things like the base oils used in the lubricants, various chemical additives,
Yeah.
the core components. When prices for these fluctuate, especially oil prices, which impact base oils,
Huh?
It directly squeezes profit margins for the lubricant manufacturers. They might have to raise their prices, which then impacts automakers, who might start looking for cheaper alternatives.
Creates a real ripple effect down the chain.
Definitely. Another challenge is waste management and disposal.
The used lubricant.
Exactly. Regulations around handling and disposing of spent lubricants are getting much stricter. Manufacturers have to think about the entire life cycle, promoting recycling and ethical disposal.
Which adds complexity and cost, I assume.
It does. It's necessary, environmentally crucial, but it adds layers to the supply chain management.
And then there's just general regulations, right? Compliance must be a headache.
It's a substantial hurdle, especially complying with complex international standards. Think about REACH in Europe, the big chemical regulation framework.
Right. Registration, evaluation, authorization, and restriction of chemicals.
Yes. Complying with that requires significant investment in testing, documentation, keeping up with changes. It takes resources, time, and money.
That could otherwise be spent on R&D?
Potentially, yes.
Yeah.
It's a balancing act for these companies, ensuring safety and compliance while still driving innovation.
Okay, so challenges exist, but the overall trend is growth, driven by innovation. What are the most exciting future opportunities or trends you see?
Well, one really prominent trend is the move towards sustainable and environmentally friendly lubricants.
Greener options.
Exactly. Bio-based lubricants, biodegradable ones. This isn't just optional anymore. It's being pushed by regulations and, importantly, by customer demand all along the chain. People want greener manufacturing.
That makes sense. What else? You mentioned something about smart tech?
Ah, yes. Smart lubrication technologies. This is really fascinating. It involves using sensors and IoT Internet of Things devices.
How would that work? Sensors in the lubricant system.
Essentially, yes. Real-time monitoring. Imagine sensors telling you precisely when and where lubricant needs to be applied or replaced, maybe even analyzing its condition.
Like predictive maintenance, but for lubrication.
Exactly. It could optimize how much lubricant is used, dramatically reduce waste, boost efficiency, and even make the lubricants last longer. It's a potential game changer.
Wow. Okay, what other opportunities? We talked about lightweight materials.
Right. The increasing use of aluminum and magnesium alloys isn't slowing down. This creates a direct need, an opportunity for lubricants specifically formulated for these newer materials.
They behave differently during casting?
They can, yes.
Yeah.
Different melting points, flow characteristics. So you need lubricants tailored to ensure the best performance, good flow, easy release, perfect surface finish. This drives constant innovation in lubricant chemistry.
And that leads to the final point, maybe, advanced formulation chemistry.
Precisely. It all ties together. Manufacturers will keep pushing R&D to create formulas with even better heat stability, better anti-wear properties, leading to superior surface finishes on the cast parts.
Which ultimately means better quality car parts and maybe lower costs.
That's the goal. Reducing operational costs for the automakers and improving the final product quality.
So wrapping this up, it's clear this isn't some sleepy niche market. The automotive die-casting lubricant space is really dynamic, growing, and facing some fascinating shifts.
It really is. It's like a hidden engine powering a lot of the progress we see in the modern auto industry.
And the key takeaway for you, the listener, is that the efficiency, the performance, even the environmental impact of these seemingly small volume fluids
Directly connects to the quality, the cost, and the green credentials of the cars you see and maybe drive every single day. They enable so much of what we take for granted.
So here's something to think about. We've talked a lot about the push for sustainable, bio-based lubricants in automotive. How might that trend, or maybe those smart lubrication technologies, ripple outwards?
Good question. Could it influence how things are made in completely different industries that also need high-precision metal parts? Think aerospace, medical devices, electronics.
Could the innovations happening here spark a much broader revolution in how we approach industrial lubrication across the board? Something to ponder.